Hello, this is Patrick at OneCNC West, and what we're going to do in this training video is continue to apply toolpath to our part using OneCNC Mill Expert. Why don't we begin by applying a finish operation to both of the bosses. To do this, let's head over to the Command Manager and select our model toolpaths. From here, we're going to be using Z-level finish. And just like with our previous machining operations, the very first dialog box is where we define a tool. In this example, let's define a tool manually. This is going to be in turret position number 3. I'm going to leave the RPM at 4,500. Feed rate, I'm going to up to 30 inches a minute. That looks good. For the holder, I'm going to be using a 1/2 inch side lock. We'll click OK to that. I'm going to adjust the overall length just a little bit. I'm going to make that 1 inch 500 thousandths, and for the flute length, I'm going to make that 1 inch 250 thousandths. We're going to be using a 1/4 inch diameter ball end mill. I think all this looks good, so let's click next on that. Let's take a look at our clearances and depths now. For a rapid Z plane, which is our Z safety plane, that's set to 200 thousandths. I think that looks fine. Plunge clearance at 50 thousandths. That's fine. That's where the tool is going to start to feed down. Let's click next on that. Now for approach style. This is how the tool is going to approach for each depth of cut. We have vertical approach. This is where the tool feeds straight down, engages the material, and then performs its depth of cut. Vertical zigzag sides will use a zigzag approach for each depth of cut. Radial approach will arc on and arc off for each depth of cut. And then we have a ramp boundary approach. I'm going to be using the radial approach. And for the radial radius, I'm going to be using 150 thousandths. I think that looks good. Let's come down here and make sure that our cut direction is set to climb milling. That looks good. We'll click next to that. I'm going to be using a constant depth of cut of 20 thousandths. Very good. Leave for finish. We're going to leave that set to 0 because this is going to be a finish pass. And for tolerance, we'll use the default setting of 2/10. Let's click next on that. Now for the custom levels, this is where you can add additional levels for each depth of cut. You can use manual, and this is where you can type in different values for each depth of cut. And you can also use this option called find flat areas to ensure that you'll have a depth of cut on every flat area of the part. For this, we can leave this set to none. Let's click next on this. For boundary type, we're going to make sure that we use picked because we want to pick this rectangular boundary that we created earlier. For tool placement, there's 3 different options. You have outside boundary, none, and inside boundary. Simply put, outside boundary means the tool can go past the boundary until the tool becomes tangent to the boundary. None means the tool can go past the boundary until the center line of tool reaches the boundary. Inside boundary means the tool will stay inside the boundary until the tool becomes tangent. For this, I'm going to be using none. Now in the lower right-hand corner, this defines the Z envelope in which the toolpath will be constrained. For example, if this was set to Z automatic and we had 50 thousandths in there, OneCNC will scan the solid model, add 50 thousandths to the top, 50 thousandths to the bottom, and the toolpath will be constrained within that Z envelope. If you don't want to use automatic, you can uncheck this and you can type in whatever values you want. Why don't we type in 0 for Z top, and for the bottom, I'm going to type in -1 inch. That way the toolpath is going to be constrained along the Z axis within these parameters. All right, let's click Finished. Now we need to select the boundary to contain the toolpath. We can take our cursor anywhere along this wireframe boundary and simply left click, and then when finished, we can right-hand mouse click to let OneCNC generate the toolpath. All right, this looks good, but we can do much better. Let me explain. Let's take this into the toolpath simulation. I'm going to right-hand mouse click on the toolpath group and select Simulate Rest. We're going to be using that solid model we created earlier for the stock, so we're going to leave this option set to stock model. Let's click OK. All right, let's speed this up just a little bit. Here's our facing operation. And now we're seeing our roughing operation. Now what I'd like to do is focus your attention on the Z-level finish machining operation. We're switching to a ball end mill. And because we didn't use a modified boundary or caps, notice how the tool machines inside of the counterbores. Now we can stop that. And again, there's two ways to do this. We can create modified boundaries or we can create cap geometry. Let's take a look at creating cap geometry and the benefits that they provide. All right, let's exit out of the toolpath simulator by heading up to the upper right-hand corner and clicking on the X. So let's talk a little bit about cap geometry. Cap geometry is used to help control toolpath. In this example, we can use cap geometry to keep the tools from machining inside of the counterbores. Now, I suggest creating a brand new layer for your cap geometry. That way you can always toggle it on and off. So let's head into the layer browser in the lower right-hand corner, right-hand mouse click, and select Add Layer. Let's rename the layer by double-clicking, and for the name, let's simply call this Caps. That looks good, so let's click OK to that. Now, with the Caps layer highlighted, any geometry that we create will be placed on this layer. Let's first extract some wireframe geometry. I'm going to head over to the Command Manager, and within our Model Tools, I'm going to use this option called Extract an Edge. I'm just going to take my cursor and I'm going to left-click at the very top of the chamfer for each one of the holes. A left-click, 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 left-click. Let's do the same for the big circular pocket as well. Let's left-click there. And why don't we do the same process for the two holes on the tapered face? With that completed, we can right-hand mouse click. All right, let's turn our part layer off and take a look at the geometry. What we're going to do now is create surfaces from this wireframe geometry. It's very easy to do. First of all, I think I am going to change the color. I'm going to change this to, how about we use gold for a color? Let's head over to the Command Manager, select our Surface Tools, and we're going to be using the option called Surface from Curves. All we need to do is take our cursor and left-click each one of these wireframe boundaries to create the cap surface geometry. When we're done, we can right-hand mouse click. Now, it's important to note that the Create Surface from Curves command only works on geometry at the same Z level. Because of this, we're going to need to execute the command 2 more times. Once for the large circular pocket, and again for the 2 holes on the tapered surface. Very good. Let's turn our part layer back on, and now you can see our cap geometry. Let's take a look now at the results of using cap geometry. We're going to head back over to the NC Manager, and I'm going to tell OneCNC to regenerate the toolpath for our Z-level finished machining operation. We're going to right-hand mouse click, and I'm going to select the option called Repick Path. Now, we don't need to change any of the parameters within the dialog boxes, so we can just click Next all the way through here, and then Finished. OneCNC now wants to know if we'd like to repick the machining boundary. We don't need to do that, so let's just click No and let OneCNC generate the toolpath. Very good. You can see now the toolpath has not entered into the counterbores. The cap geometry is doing a great job. Let's confirm this by quickly simulating our toolpath. We'll head over to the Command Manager, right-hand mouse click on the toolpath group, and Simulate Rest. We'll click OK, and let OneCNC simulate the toolpath. Now, I have the simulation speed sped up here, but you can definitely see that the cap geometry has kept the tool from entering inside of the counterbores. Now, if we take a close look at our previous roughing operation, you're going to see these 2 notches that were created when the tool wandered into the counterbores on the tapered surface. Because we have cap geometry now, we could regenerate that roughing operation to get rid of the notches. In fact, why don't we do that? Let's exit out of the toolpath simulator by heading up to the upper right-hand corner and clicking on the X. Now, we do want this Z-level rough machining operation. We do want it to machine inside of the large circular pocket. So I'm going to hit the letter S on the keyboard, left click our cap surface, and then hit the letter B on the keyboard to blank or hide that. That's exactly like using this command up here, the blank tool. All right, let's regenerate our toolpath. We're going to right-hand mouse click and select Repick Path. Again, we don't need to change the parameters within the dialog box, so we're just going to click Next all the way through and then Finished. OneCNC asks if we want to repick our machining boundary, and again the answer is no. Very good. Now let's take a look at the results of this within the toolpath simulation. We'll head back to the NC Manager, right-hand mouse click, and select Simulate Rest. Stock model is perfect. We'll click OK to that. And here we go. Notice now the roughing operation isn't going to leave those notches on that tapered surface. In fact, if I rotate the view a little bit, you can see now that the notches are no longer there. All right, so that's a great example of the use of cap geometry. Now that we have our cap geometry in place, let's perform a flat area machining operation. All right, let's exit out of the toolpath simulator. Now for this machining operation, we're going to be wanting to use that cap geometry that we hid a little earlier. We can easily unhide that by heading over to the layer browser in the lower right-hand corner and just click on the little eye next to the caps layer. Very good. Now let's head over to the command manager, and from there we're going to select our model toolpaths. Now let's select the flat area machining operation. And just like with all the previous machining operations, the very first dialog box is where we define a tool. This tool is going to be in turret position number 4. For the spindle speed, I'm going to up that to 3700. That looks good. For the feed rate, I'm going to make that 35 inches a minute. We're going to be using a 1/2 inch side lock for the tool holder. We're going to be using an end mill. The overall length is going to be 1 inch 750 thousandths, and the flute length is going to be 1 inch 500 thousandths. Very good. And we're going to be using a 3/8 diameter tool. All this looks great, so let's click Next on that. Our clearances and depths look good. Rapid Z plane at 200 thousandths, and our plunge clearance at 50 thousandths. Let's click Next on that. For machining style, we have 3 different options: high-speed closed, high-speed open, and center optimized closed. We're going to be using high-speed open for this. All this looks good, so let's click Next on that. For approach style, we can use plunge, ramp helix, or ramp zigzag. For this example, I'm going to be using ramp helix. For the ramp angle, I'll use the default of 3 degrees, and for a helix diameter, I'll be using 375 thousandths. That looks good. Let's click Next on that. For step over, I'm going to be using 75% of the tool diameter, leave on side 0, default tolerance of 2/10. Let's click Next. For boundary type, we're going to use picked because we want to pick this rectangular boundary we created earlier. And for tool placement, I'm going to be using outside boundary. That's because I want to make sure the tool can get into these tight areas right here. I think our parameters for the Z envelope look good, so let's click Finished. Now all we need to do is simply left click on the wireframe boundary, and we can do that anywhere along the boundary just with the left click. And once we're done, we can right-hand mouse click to let OneCNC generate the toolpath. Very good. I think all of our machining operations are looking great, so why don't we end the video by performing a toolpath simulation. We'll quickly head over to the NC Manager, right-hand mouse click on our toolpath group, select Simulate Rest. As always, we're going to be using the solid model for our stock. We'll click OK. And here we go. There's our facing operation, our Z-level rough operation. The cap geometry is doing a great job. Coming back in now with our ball end mill. This is our Z-level finish operation. And then we'll change tools to that 1/2 inch flat 3/8 diameter end mill and perform the flat area machining operation. And we're seeing that right here. All right, that's it for this video. Thank you so much for watching, and I look forward to seeing you in the next video.